calories per gram of fat. Okay, so 10% becomes, what's 10% of 2,000? So you get 200 to 250 fat calories per day, and you get 9 calories per gram of fat. So you can have 22.22 to 27.78 grams of fat per day. I challenge you to go one day with less than that of fat. It is virtually impossible. And so the way that they did it, because clearly they're not concerned with just fat. I mean, what if the person kept their fat down to 20 grams, but it was bacon fat? Okay. So the way they did this, and the way it worked, if it ever had a mother or a face, you cannot eat it. Okay? Cannot be processed. So you can eat olives, but you can't eat olive oil. You can eat oranges, but you can't eat orange juice. If it comes in a box, if it comes in a can, you can't eat it. If there are ingredients listed on the package, you can't have it. Think about what that means. You've all been grocery shopping. You pick up a bell pepper. Are there ingredients listed on the bell pepper? It's a bell pepper! But if it's a can of green beans, it has ingredients, most of which are not good for you. You can buy fresh green beans and you can eat those. So you understand. Yes, they successfully reversed heart disease. People who were so sick that they had, walking across the parking lot to see the doctor, they had to stop and catch their breath, were able to go back to the tennis courts. But it's very, very hard to do. Obviously, it's not as simple as saying, I'll be a vegetarian. And like so many things, we figured this out by looking at other cultures where heart disease is unheard of. So, well, what do they eat? What don't they eat? Some of the healthiest people in the world don't drink milk. The whole thing about milk that we were taught as children is crap. What other? Give me one other animal on the planet that gets its milk from another animal. Do cats drink dog milk? Do giraffes drink hippopotamus milk? Why do we drink cow milk? The only milk we should have is our mommy's milk when we're babies. Milk is an animal product. It's deadly. Again, when I have these conversations with you, I'm not telling you I'm great and wonderful. Do as I do. No. I don't like milk, by the way, but that doesn't really matter. I like bacon. All right, so that's fats versus oils. As we look down letter A, fats versus oil, animal versus plants, a couple of things here taken from the chart. Just one second. Letter A, glycerol and fatty acids. Those are the components of lipids. Again, look at the chart if you need to. We don't need to go over that again. We've done that. You've written it down. Saturated versus unsaturated. We just looked at that. Trans fats. We just looked at that. Monoditriglycerides. The chart, if you need to refer back to that. We've done that. Item 3, beta oxidation and ketoacidosis. We just did that this morning. So again, we're going through letters A, B, C, D, and E, talking about functions, kind of the interesting stuff. Then we'll go back through letters A, B, C, D, and E and look at the structures, okay? The exception being the saturated versus unsaturated. We had to look at those structures to talk about the trans fats. Okay, you go ahead.
I was curious, with that diet, how do people not develop a deficiency in like iron?
There are one or two things. Another one is vitamin B12 that they have to take supplement. Have to. Because it's, I mean, I'm a carnivore. I mean, you know, I would never have this sort of problem, but so often what you see somebody who, and if you don't eat meat, hey, more power to you. I'm not criticizing you at all. But so often you see somebody who's weak, lethargic, anemic. The fastest way to fix that is to go eat a hamburger. They probably don't want to do that, and more power to them. But they probably know where they can get those ingredients. They probably know what combination of beans and things like that. But the two big ones, and there's actually three, I can't remember the third one, are iron and vitamin, a couple of the B vitamins like B12, I know for sure. Okay, so next is letter B, the phospholipids. The phospholipids, of course, are the components of cell membranes. Cell structure and function is one of the review topics on the prerequisite document, so I will not be covering those. Takes us to item 3, cholesterol. Cholesterol is interesting to talk about because we all know something about it in terms of, oh, I hope my cholesterol is not too high, or I know my dad's cholesterol is too high, or I know Mama's taking Lipitor or something to lower her cholesterol, and I've got a family history of heart disease, I better watch my cholesterol. And we see we're inundated with commercials on television about this or that cholesterol lowering drug, and so we think it's just the most horrible thing in the world. Well, it's not. Yes, it is. No, it's not. Let's go back to cell structure and function, even though we're not going to talk about it, because it's on the prerequisite document of information you're supposed to review on your own. But if we look at that phospholipid bilayer, as we did on Monday, in some other context, oh, the squiggly lines. Guess what's holding those phospholipids together?
Cholesterol.
Cholesterol is hydrophobic. It's not between the phosphate groups. It's not between the hydrophilic regions. It's between the hydrocarbon chains, the nonpolar regions. It's holding our cell membranes together. So just as you know about all of the different proteins found in cell membranes for transport, recognition, etc., we've got cholesterol. If you didn't have any cholesterol, you'd fall apart. So it's in our cell membranes. Okay, another reason we have to have cholesterol, it is used to make our steroids. So if you don't have any cholesterol, or not enough cholesterol, you can't make estrogen. You can't make testosterone. You can't make cortisone. You can't make aldosterone. Any steroid. In fact, guess what the word steroid means? Formed from cholesterol. What is a steroid, Mom, Dad? What is a steroid? It's a hormone made from cholesterol, son, daughter. Steroids are hormones made from cholesterol. So, used to make steroids. Testosterone, estrogen, cortisone. Now, there are many, many, many varieties of both of these. You don't need to write them down, but it's just an awareness thing, because as I write the next one down, somebody's going to say, well, what about hydrocortisone? Or what about cortisol? For our purposes, there's no difference. Okay, that's a topic for a very advanced biochemistry class. So what about estradiol? What about dihydroalpha testosterone? For our purposes, it doesn't matter. They're all the same thing. So if you read cortisol, just translate it to cortisone. It doesn't matter. Won't even bother you with the fourth one. I had named it. It's aldosterone, but you don't have to write that one down. So we can't make any of those things without cortisol. Now what about our health? Well, we go to the doctor and we have a lipid profile. And that lipid profile looks at our triglycerides, our LDL, this is our so-called bad cholesterol, our HDL, which is our so-called good cholesterol. This lipid profile is looking at all of these things in the blood. So it's not that we don't want any triglycerides or any cholesterol. We don't want too much. The other element that goes into this is total cholesterol. So again, it's not that we don't want any of those things. You've got to have fat. If you don't have fat, you can't make phospholipids. You can't make cell membranes. You've got to have cholesterol to make your steroids, to make your cell membranes. You just don't want too much. Let me leave you quickly with one thing that you can perhaps relate to. So if cholesterol is used to make estrogen and testosterone, well, estrogen and testosterone go into stimulating bone density. Now, I don't care whether you draw from a personal experience or a friend or a famous athlete or a fictitious movie on TV. But I want you to picture somebody who's too skinny, somebody whose body fat is too low. If their body fat is too low, their cholesterol is going to be too low. Their estrogen and testosterone are going to be low. Their bones break. They're doing something that an ordinary person does with no consequences. And when they do it, the bone in their foot shatters. They have weak. Can anybody relate to this? Don't tell me how you can relate to it. Personal level, friend, relative, movie on TV, made up, stupid joke. But yeah, body fat's too low, cholesterol's too low, hormones too low, bone mass is too low, bones break, you're walking on the street, bone in your foot shatters. What would happen to a female that would not happen to a male, that would give her a little insight into this problem? Would she stop menstruating? Yes. So when women are so skinny that they don't menstruate, they're asking for this. We'll talk about this in significant more detail on Monday in the context of the steroids.
We have a picture